This video will introduce OpenDDS security using an Industrial Internet of Things demo application. Your presenter today is Adam Mitz, Principal Software Engineer at OCI and Lead Engineer for OpenDDS.
This video will focus on OpenDDS's new security features, but before we get there, let's talk a minute about what is OpenDDS. OpenDDS is an open source and widely adopted standards-based real-time publish-subscribe solution for distributed systems. Our project website is opendds.org, and our project repository lives on GitHub at the address you see on your screen. Developers use OpenDDS as a framework for enabling C++ and Java applications to distribute data over the network using a publish-subscribe architecture. Unlike low-level transport protocols, the OpenDDS middleware is aware of the schema and semantics of the data. OpenDDS helps shield application developers from the inherent complexities of distributed computing. OpenDDS is OCI's implementation of the Object Management Group's standard Data Distribution Service, or DDS for short. OpenDDS interoperates with other DDS products. The DDS security specification is relatively new, and we'll be focusing on that in this video. The DDS security specification has three main areas: authentication of participating applications, access control by topic, and actually protecting the data in flight. And that can be done by encryption and/or message authentication. OpenDDS's security features are currently in development. We expect a beta release in August of 2018. This demo will be based on three software components. A device or simulator is shown on the left of this slide. The device or the simulator, in this case we'll just be using a simulator, will be sending valve pressure readings out on the network using DDS to communicate with the smart device web app. So from DDS's point of view, this device publishes data and the web app subscribes to it. We've set up the device and simulator to run on VxWorks 7 on the BeagleBone Black, which is an ARM development board, a lot like a Raspberry Pi. But it can also run on any common desktop operating system or servers, so Windows, Linux, Mac OS. The Smart Device Web App Server is developed using OpenDDS's Node.js module. So the application logic is in JavaScript, as any Node.js application is, but it uses the OpenDDS libraries internally. Then the third component is the user interface. So that's running in a web browser. So that's the Smart Device client of the web app. And these communicate with each other over HTTP or HTTPS and use WebSocket to push live data from the server to the client. We'll see the demo in just a second. Before we do, let's look at it as a deployment. So in order to show what DDS security can do, we'll have two instances of the device side running, which in this case is just the simulator. But this is the device without DDS security enabled. This box below it represents the device with DDS security enabled. Aside from the security configuration, which as we note here includes the certificate, private key, and signed configuration files, there's nothing different in the software. Both of these publish to the DDS domain, one without security and one with security. To simulate a scenario that would actually require security, what we're going to show here is that the device without DDS security publishes invalid data, right? Instead of actually showing what the valve pressure is reading, this is an imposter on the network sending invalid values that are, in our case, 100 times higher than they should be. Now let's look at the receiving side. On the top, we're showing the Smart Device Web App without DDS security enabled. And below, the Smart Device Web App with DDS security enabled. As we've illustrated with the different colored lines representing data flows here, the Smart Device Web App with DDS security will not see this imposter data. because a secure authentication could not be established between this application, the smart device with DDS security, and this one, the device without DDS security. Similarly, if we run the receiver side, the smart device web app without DDS security enabled, in our current configuration, it won't see this blue data flow. It won't see the data coming from the security device, the device with security, because that data is encrypted and it has no decryption keys for that data. So let's take a look at the demo in action. What we're seeing here in the demo are these two side-by-side applications. The one with the blue title banner and the closed padlock is the secure receiver. And we see it receiving these pressure readings from the valves that vary between 1 and 100. And just to make the application a little bit more visually interesting, alerts will show up when it's above 75, for example. On the right side of the screen, we have the same application but running without the secured configuration. So we show that with the red banner and the open padlock. And what we're seeing here is that these pressure readings are way off. These are 100 times higher than they're supposed to be. So these are coming from the application running without DDS security. And of course, that alert pops up very high pressure. If we were to look at the physical device, if there was a physical device, there really wouldn't be a high pressure error. It's just this simulated application sending invalid data on the network. So what we're seeing here, if you take a look at some of the details, are really just the contents of these DDS messages. So there's a counter, there's some Booleans, there's this pressure reading. But you'll notice that the instance is the same, the 5010015. We're seeing that same instance on both sides. What this shows is that this data really is the same data from the DDS point of view. So the topic that it's writing to and the DDS instance that's being updated is the same. It's the security features of the secure configuration of OpenDDS that's allowing the blue application to decrypt the correct data and to ignore the invalid data that happens to be showing up on the same group, multicast group port, for example. So for more information about OpenDDS security, please see the resources listed here, including the DDS project page and repository. OCI offers support, training, consulting, and custom development relating to OpenDDS. And we will also be hosting a free webinar on August 22nd, 2018. See the URL listed here, and that will be available to watch in case you are listening to this after that date. We've also presented a webinar last January that's archived, as you see here on brighttalk.com, that was with the object management group, designing a distributed application using DDS QoS. If you'd like to learn more about DDS's features in general, not relating to security, that's a good place to start as well. Thank you very much.